right.
Plus cos x.
Yep.
Is equal to 0.
All right. And what do they
now
want you to do
solve
with
for
that?
x between the interval minus 90 and 180.
Okay. All right. I don't want to give out too much information without first probing what you can do here, Masivuye. What could you do? Did you know where to start the question?
You must change the sign to x.
Good. So what would you change it into?
2 sine x cos x.
Great stuff. All right. And are you going to change anything else in the rest of the equation?
I first thought of changing the cos to x, the cos squared x.
And why did you not do that? Why did you kind of decide that that wasn't a good idea?
I changed, then I became stuck.
Okay, because remember that if you actually change it, cos squared x is the same as 1 minus sine squared x. Do you agree?
Yes.
Now, just think about that. Count up how many terms you would have. You'd have 1, 2, 3, 4, 5 terms. Okay, and 5 terms is not a great number for the kind of procedure that we're about to do. If we leave it, Masivuye, how many terms are we working with?
We'll be working with 4 terms.
4 terms, okay. So in grade 9, when you started off factorization, one of the most important things that they taught you was if there are 2 terms, or 3 terms, or 4 terms, first try to take out a common factor. Can you take out a common factor here at all from all 4 of these terms?
No.
No, okay. Then they should have said to you, right, if you've got 2 terms, is it the difference of 2 squares? If you've got 3 terms, what would you look out for?
You look for if the 3 terms are you're able to factorize them.
Okay, factorize using what technique? If it's 3 terms, what does it normally suggest you're going to use as a factorization technique? So let's say
you're going to open 2 brackets.
And then you're going to use a technique called trinomial factorization, aren't you?
Yes.
All right. Now, that isn't what we're going to do here because we haven't got 3 terms. We've got 4 terms. So, are you aware of what we normally do when we have 4 terms?
I think we're going to group.
You're going to group. Okay, great. So, I tell you what, let's take the first 2 terms and let's group them. And then let's take the second 2 terms and let's group them. Okay, and see how we go. So, having taken the first 2 terms, what can you see that they have as a common factor?
2 sine x.
Great stuff. All right, and what are we going to leave behind in that bracket once we've taken the 2 sine x out as the common factor?
I'm going to leave cos x plus 1.
Excellent. Right, and now from the next 2 terms, what do you see that they have in common?
Cos x.
Cos x, great. And what do you leave behind?
Cos x plus 1.
Okay. Now can you see that what you've done is you have successfully got a cos x plus 1 here and a cos x plus 1 there. So what does that now mean you can do?
It means that you can take the cos x plus 1 as a common factor.
Okay. Keep on going. What is my next bracket going to read?
It's going to be cos x plus 1 into 2 sine x plus cos x.
And that we put equal to 0. Now what we have in front of us, Masivuye, is just 2 easy equations that we're going to now be able to solve for x. All right? You confident that you can do that with me?
Yes.
Okay. All right. Taking the first bracket, I'm sure that you will agree that we would be able to get cos x is equal to minus 1 from that particular factor.
Yes.
Or taking the other bracket, we would get 2 sine x is equal to negative cos x. Great. Okay. The left-hand one, cos x equals minus 1. How do you solve that? How do you feel most comfortable solving that equation?
You're going to, I think you're going to, the inverse of the cos 1.
Okay, just repeat what you said. What are you going to do?
The inverse of cos 1.
Okay, the inverse of cos 1. So you're going to put it into your calculator, are you? And you're going to find a reference angle. All right, have you got your calculator there in front of you?
Yes.
Okay, so what are you getting?
and getting 0.
You're getting 0. So you're getting your reference angle to be 0. All right? Now, is that going to be your actual answer, or is that just your reference angle?
No, it's your reference angle. You must check, because we've got the negative sign in front of the 1, so
Good.
you must check where cos is negative.
Okay. Now, I'm just going to draw your attention to the cos graph very quickly, because can you see that at 0, the answer is positive 1, but at 180, the answer is negative 1.
Yes.
Do you agree?
Yes.
Okay. So our answer here is going to be 180 plus K360. Okay?
Yes.
All right, Masibuya, I'm going to just speed up a little bit on this right-hand side so that we can get through the entire question. Do we know that in order to solve this one, we're going to divide both sides through by cos?
Sin x.
By cos x, love, rather than sin x, because if we divide by sin, we're going to land up with a cot. It's better to divide by cos. So we're actually going to divide this side by cos x and this side by cos x. And so that's going to leave us with 2 tan x is minus 1. And so consequently, tan x is negative 1/2.
Yes.
Right. Now you're going to go to your calculator, aren't you? And you're going to second function tan. And what are you going to get your reference angle to be?
26,57.
Okay. Now, remember that's just your reference angle. You are now going to have to go and find the two solutions where tan is negative, and that's going to happen in your second quadrant and in your fourth quadrant. And then remember, you're going to have to add revolutions of 180 because it's a tan equation and the period is 180. Okay. Once you've got those solutions, and I know I'm rushing you, but once you've got those solutions, you would then, I'm just going to write down the actual answers for you so that you can check it. The answers are 153,43 as well as 333,4 degrees. And then, of course, you just let K take values and you add on or subtract amounts of K360. Okay, is that enough to help you?
Yes.
Great. Okay, we hope to hear from you again in this build-up to your exams, and I wish you luck for your other subjects.